This is not what you think it is. Hello and welcome back to another Out of Spec Reviews video, and welcome to the tent now where we have filmed some pretty interesting videos with our friends at Magna. We're in Graz, Austria, and this is the EtelligentReach. Okay, I know what you're thinking it looks like, but it's not that. This is a complete development vehicle for Magna that is showcasing some of the most mind-blowing technology from a driving standpoint. Not only will this technology make you faster, it'll also make you safer. And to be totally honest, I'm just super pumped up about it. This is probably the biggest innovation I've been looking for paired with electric drivetrains ever, and never experienced anything like this, genuinely. So I'm so excited to bring you along for my first experience in the EtelligentReach with this powertrain system, braking system. There's a lot of nerdy stuff to get into. We're gonna explain it all, and hopefully you'll learn a few things along the way. So we just got in from the test track, which is coming up later in the video, but you know, stay tuned because we are skidding around in this awesome car. But let me talk a little bit about how this is laid out. We have a front electric motor, very typical setup up front, but all the fun stuff's happening in the rear from a mechanical standpoint. We have a rear electric motor. Do you know the kilowatt front and rear?
160.
160 each. Yep, so 160 kilowatt peak motors each, and these are all Magna motors, right? Yeah, so Magna motors in them, which is pretty sweet. But we also have a mechanical torque vectoring differential on the back that's activated with discs. Remember when we did the Volkswagen Golf R review and we talked about how you can change the modes and the driving behavior on throttle of that car? Very similar setup here with different tuning, different units, much higher torque loads, of course, with something like this. But essentially what this means is most electric cars, very basic scenario. You come into a corner, you got the car leaned over on the side, the inside tires have almost no traction on them. If you apply throttle, it can, with an open differential at least, just spin the inside tires and you're losing traction. And we get this a lot when we review sometimes front wheel drive EVs, when we're flooring it, like for example in a Hyundai Kona EV onto a highway. We've done videos on this, and it spins the inside tire. This type of technology will not only try and match the wheel speeds, we've talked about locking differentials, but it can actually overdrive the outside wheel and tire, so it can apply a significant amount of torque on the rear outside wheel and tire. And what that means is you're able to control yaw of the vehicle without grabbing brakes if you want to. So you can shift the power around. You can also longitudinally and laterally adjust power no matter how you want. That's cool. We've experienced this before. Nothing special. I mean, it's special to do it with an EV, but it's pretty expected. What's not expected, what this can do is it can do it off throttle. Torque vectoring is really cool when you're driving around and you come into a corner and you floor it, especially in an all-wheel drive system, and you start to feel a little bit of rotation on the rear. It's fun for us. What we've never been able to do with that technology is actually do that off of the accelerator pedal. And that's purely because you're not distributing any torque to the tires. This has the craziest sort of braking integrated system that I've ever experienced. So essentially what happens is if you're doing this off throttle, it can actually change the braking around a little bit, and it's essentially utilizing more of the tire in a corner. For example, we were just skidding around on the racetrack, and you can see this tire has a lot of wear on it. And that's very typical of all-wheel drive systems, to have front tire wear on the outside. And this happens to us all the time. You know, we show you tires like this that just look destroyed after a couple minutes. But what we've never really seen before as well is the rear tire looking very consistent with the front. And that's so important because, you know, time on a racetrack or safety out on the road means utilizing all of the available grip at any time. And this type of technology, which we're going to learn about how it works and demonstrate this, is allowing you in all driving scenarios, not just on throttle, to utilize the available grip when possible. So what do you say we jump in the EtelligentReach, we head out on the testing track with some engineers, and we figure out how all of this works and what it actually means in the real world. Then at the end of the video, I'm going to drive it and you'll see my reactions behind the wheel. But a little bit of a teaser, I'm just giggling the whole time. And yes, you can do big skids if you want to.
If you take a look inside here, you can see our brake-by-wire units we are utilizing in this one. So the approach in this one is we have the integration of the brakes. And in this one, the way to make it happen was with additional hardware. This means this one is carrying 2 e-drives from company Magna and 4 brake-by-wire units from one of our development partners.
So you
This
have an
means
individual brake-by-wire for each wheel.
individual brake-by-wire for each wheel, yeah.
That's really
Four
fascinating.
4 times the same unit. This means this one is good for functional development, so we can develop whatever functionality that will be necessary. That will be necessary or relevant later on for production. Architecture-wise, it's not on the point. This is what we know.
Yeah.
Because you would not put 4 separate brake-by-wire units in one crazy car.
So will you have to create a new type of braking system for this?
Yes, but this is what we're into at the moment. So we're working with partners out of the brake supplier business to find a serial approach.
This is such a great idea because our audience, they're already like, Kyle always complains about all of the braking in every electric car, and this strategy is the only way to do it properly. But it doesn't exist yet.
It doesn't exist yet, yeah. That's the funny thing. And this was also the reason that we are pushing for that, because it was quite big effort, to be honest, and a big step, technical-wise. But for us, it's so relevant, and there's a clear benefit in all functional attributes, as we discussed before. We can improve efficiency, we can improve controllability and safety, we can improve performance, and we can also improve all the convenience, comfort stuff with the brake blending and other features you might know that are somehow critical.
Yeah, incredibly important. I'm really looking forward to driving this and feeling it, because this is the most important topic to not only make a safety approach, but also to improve drivability for us drivers, right? Because now the car can actually do what we're asking it to do, and we don't get this very odd and vague brake pedal feel that sometimes we have to drive differently for the request because we know the car is not going to do what we want to do. So this is going to be really fun to play around with.
Okay. Curious for your feedback later.
Yeah, I'm looking forward to it.
Now you join us out on the test track, and what are we going to see?
What are we going to see? We are going to see how you can improve drivability by, I would say, putting torque to a certain wheel in a certain driving condition. Typically you call this torque vectoring, but torque vectoring is like a password. So what we actually do is, on the one hand, we are putting torque front axle or rear axle, left or right side with the conventional system, means with the 2 e-drives and the 2 clutches on the rear.
Yes.
And as a next step, in an overlay, we integrate the brakes. This means with the standard torque vectoring, we can split the torque accordingly, the existing torque. With the advanced brake integration torque vectoring, we can also split torque if there is no driver torque request.
Right.
Which is kind of interesting,
Yeah.
function-wise, and which leads us to the point where we can transform the torque vectoring functionality from a performance feature also to a safety feature, means to real-life drivability improvement.
Right. This is very useful in a safety situation, where especially if you're on a loamy surface, a snowy, icy surface, let's just say, you can put in much less steering input, have the tires all working in the direction you want it to go, rather than just relying on maybe 2 tires. You can bring the others in to help you out.
Exactly. Yeah.
And what about in a performance setting, though, for lap times and everything? You might get 1 faster lap time with this, but then will the brakes heat up, or how does this, what's the trade-off?
The good thing is, in this configuration, we are utilizing 2 e-drives and 2 clutches on the rear.
Yeah.
This means in driving conditions where you have a lot of torque, we do transmit the torque by the e-drives and the clutches, so there is no power loss.
So you're not
in
doing
the
this
brakes.
with the brakes, yeah.
Exactly. And in the throttle off condition, where it's about stability, controllability, safety, you don't need much torque that is applied to control the behavior of the car on the one hand, and you only do it for very short time. So thermal availability, thermal stress, and wear of the brakes is not really a topic.
And one important factor we spoke about earlier too is just in terms of driver feel, is many braking systems have 2 different control units on them. You have your friction brake control unit, you have your regen brake control unit. They operate on totally different systems. They're not so interconnected, and we always mention in our videos, like, this feels so weird in certain cars, sometimes things like this. And even being able to maintain regen braking through an anti-lock brake situation is something you can do.
Exactly, yeah. So we typically call it two different systems or two different domains. And sometimes, as you mentioned, the two domains are fighting each other. We have the domain drive system and the domain brake system, and each of them has a separate control. Each of them are utilizing a separate physical vehicle model and have a different control strategy.
And this just leads to such weird
Exactly.
feelings.
And
so this
what we
is
did
one.
is we are merging. Yeah? We only have one controller, one physical vehicle model, and one strategy behind to control.
Well, I have to
drivability
tell
in
you,
this matter.
I'm so happy you've been working on this, because these are the problems that keep me awake at night.
Really?
Yeah, every night. Yeah, it drives me nuts, and so I'm really happy that there are such experts like you and your colleagues that genuinely are fixing the problems that I know I live a very nice life, and if this is my biggest problem, we're doing okay, but this is a big problem to me.
That's a first world problem, as we
Yes.
call it. Yeah?
Yes.
But we will really try hard to put it to production quite soon, so you're happy.
Great, that's awesome.
Customer
I'm
done,
looking
yeah?
forward to it. Yeah. So let's try it out.
All right. So to understand the system capability, I've chosen to go on the circle. It actually has a radius of 50 meters. And the maneuvers I'm going to do next is I'm repeating the same maneuver, same initial speed, same steering input in different application settings. And the first thing we start with is called 50-50 mode, and you can guess what it is. It's a fixed torque repetition, so no vectoring, no fancy yaw
Right,
control,
just
no nothing.
standard, even power, front and rear.
And
And
left.
we'll get all settled
And
in
left
leaning
turn.
this right now.
Oh, it's okay. So we are choosing an initial speed which is roughly 70 kph.
Yeah.
The steering input is about 80 degree, 85 degree.
Yeah.
And then I just slightly apply the throttle.
Yeah. And we've gone off the road.
We are off the road. We have the understeer behavior,
Yeah.
which is very typical for an orbit-driven car.
Yes.
Without the torque vectoring feature, but that's our baseline.
Yes.
So the next step we can do now is we go through different torque vectoring settings without the brake. And the first one we would call comfort mode.
Okay.
So comfort mode would be all the driving condition setting,
Right.
same initial speed, same steering input. The white line is always in the middle of the car.
Yep.
Throttle input. And
Yeah.
you will see I can already go a bit faster.
Oh yes, absolutely.
But if I really push it,
yeah, you still go wide.
why do we do this? What
Yeah,
do you
this
think?
is controllable. It's safety. Anyone can just lift off at this point and tuck the nose back in.
Yes, it's something like a driver warning. So this means we're doing this on purpose. This means you're stable, we keep you under control, we keep you neutral. If you're coming towards the physical limit, we still give the car a certain understeer tendency
Yes.
for the driver to understand what's going on. Next mode would be sport. What would be your expectation of sport?
Yeah, sport would be fastest lap time, so not full drifting, but just getting the things to work as hard as possible to get us around. Is that how you approach this?
Exactly. So same speed. If I now apply the throttle,
Yeah. No big drifts, just everything working super hard, staying pretty nice in line.
and the funny thing is, there is no correction on the steering.
No,
as
you're
I
just
say.
keeping it.
Typically, you always need to close the steering, open the steering, stuff like that.
Yeah.
We are controlling the yaw behavior just by putting the torque on the four wheels accordingly.
It's really cool stuff. And there's no like big chunks and clunks and everything happening.
No,
It's
nothing.
just all software.
All
And
right.
now we're in the fun setting.
Now we're in so-called dynamic mode. Yeah?
Yeah.
So if I repeat the same maneuver and you tell me later on what you feel, same
Yeah.
speed, same steering input. So this is what we get. So with the same steering input, the same throttle input, the same speed, we can really put the tail out. And
Yeah. This is how
provide
we
a
drive
very-
to the grocery store in America, like
Yeah,
this.
you
Yeah,
typically
full
do,
skids.
yeah.
Yeah. Mhm.
I truly believe
So
it.
I would only drive in this mode. This is really cool.
Yeah?
So you're basically through software saying, okay, we can do whatever you want. You have a total variability on the rear axle. You have brakes on the front axle to assist. You have an e-machine front and rear. And you're like, here's all the ways we can tune it. And the idea really is Magna's not building a car. You could take to a customer and say, look at this crazy adjustability, and you can either limit this function. For example, if it's not a sporty car, you wouldn't need this drifting function, although I think every car should have this. And then, and really for an OE customer who would be sitting where I'm sitting right now, this must just blow their mind.
Yeah, but that's only the first step, to be honest. So this was only standard torque vectoring without
Yes.
brakes. But now there comes a certain functional limit. We discussed this before. In emergency situation, in critical situations, people are typically releasing the throttle, and if they are well trained, they are also applying the brake. if you release the throttle, there is no torque to be transmitted, so there is no vectoring capability.
Right, so you're just relying on that outside tire for the most part, doing all the work.
Exactly. And what does this mean in real life? If I'm going a bit faster and try to turn the steering wheel without the brake support, like now, you can see I'm
the worst noise ever.
I'm applying additional 360 degree of steering input, but
Yes.
the car is not reacting.
Sure.
So now comes the point. If we now activate the brake functionality, we can either put existing torque where we want it, or in throttle off, we can apply torque on one side and kill it on the other
With braking,
with the brakes, or we can apply torque with the clutches on one side
with regen.
and brake the other with regen.
Yeah, regen.
which
torque
is
vectoring.
the funny part, and
Yeah.
and this now gives us the opportunity to have a full vectoring capability without any driver request. So if I now choose a constant speed a bit below the limit,
Yep.
75 kph, and if I now turn the wheel,
Oh, you can feel it grabbing you.
yeah, you can feel.
Yes. And then it pulls you right out.
Yeah, that's a funny thing. So you can always steer the car no matter how close you are to the physical limit. And if I now do the worst case situation, so we are going on the physical limit through a corner, and we think about an avoidance maneuver, means we need to have to do a lane change.
Yep.
On the physical limit, in, out, there we are.
Yeah, and you didn't even have to come across center.
Did you watch my steering? Yeah.
You just went through
Just like
straight.
this, that.
Yep.
And typically some people are able to do the lane change part one,
Yeah.
means to get to the other lane, but at least at the stabilization they are completely gone.
Right, of course.
And the funny part is you cannot feel the vehicle is doing something, but it's just putting you
This is
aside
like
for
driving
one
in a
full lane.
video game. It feels so wild because we're in one car and we've just experienced 10 different vehicle setups.
Yeah, this was exactly the target. So this is
This
relevant.
is wild.
Maybe for one car it's a bit too much, but
Yeah,
for
it's
the
very
different
aggressive,
platform
but to show.
application we typically have, that's exactly what we need to achieve.
Holy smokes. So, I mean, my mind is blown. I'm sorry, I should be somewhat professional. This is freaking awesome because we're literally playing around with on throttle vectoring and vehicle modeling in terms of controlling yaw and on braking. I've never experienced this with braking. Is there any production car that does this?
Not existing yet, yeah.
Wow.
So you can either brake or drive, but you have no production car which is using one control, and you also have no production car which is fully compensating the brake by the drive system.
This is crazy.
All right, I think now it's up to you. Just one more lap, which is funny. So this is the full thing. You see this? It's like driving a boat,
Yeah.
and I don't have any stress to control it.
Right.
See this?
Yeah.
Like, that's all. And that's the reason some of our customers say the system is making a car a better driver,
Yeah. Yeah.
which was exactly the target.
Yeah. I mean, it's just so freaking incredible. I love this.
All right, now it's up to you.
Awesome. Well, we've gone left a lot, so these tires are gone, so we'll go right. So let's do brakes off.
Okay.
Will I feel a difference in the brake pedal at all?
Some in the stiffness of the brake pedal,
Yeah.
which we could not adapt in this case, but it's not a relevant difference. But
Okay.
this is the standard setting we would provide without the brake integration.
Right.
So
okay.
you have torque vectoring front rear, left right, conservative setting means comfort mode, and the brake integration now is off.
For so heavy, it's really not too bad. Okay, well let me just get a feel for it really quick. Get all
Do whatever
comfortable
you
in
like.
the cabin.
There's nobody out.
Right?
Should be good.
Okay. So we'll just come around. We are now driving in the EtelligentReach demonstrator, and we have it just basically in full normal functionality, which is how you would drive the car normally. And it feels like a normal electric vehicle, but it's your motors, front and rear.
Exactly.
So we have to try some acceleration. So we'll just nail it from a launch. Still quite quick, ramps up, sounds really good too actually. The noise is not bad. And let's I guess try some stuff on. So I'm gonna just go around the loop really quick in sort of normal function if that's okay.
Okay.
And then yeah, then maybe we'll even hit the low mu slippery surface and slide it around a little bit if that's all right.
Whatever you like. We are on
Okay.
the test track, so you're
Yeah.
free to make your choice.
Great. So we'll just kind of come in here, get a sense for the vehicle set. Yeah. So, pretty on the slip for bits. So look, you can see I'm applying more steering, have to back off a little bit. And then as I apply throttle, you see we go straight, a little bit more throttle, straight, and then off throttle, of course, it's not doing anything super crazy. So let's try with the brake blend situation on now. And how do we do that? Or the brake by wire, sorry?
I would say you would see it the best way if you compare sport without the brakes.
Okay.
And sport with the brakes. So maybe we do another lap without the brakes first.
Sounds great. So this is just sort of no special braking function.
No special braking function, but as long as you accelerate hard, we try to support you as good as possible with the vectoring. In throttle off, we don't have any capability.
Right, so throttle off's not going to do anything. But if I give it big throttle, a little bit of on, certainly. So off throttle, of course, nothing. This feels quite nice. You can see it pulls us forward as I give a big power application, which is nice. Okay.
All right, so now in comparison, we apply the brake integration functionality.
Okay.
In addition, this means we are now splitting torque accordingly, means splitting the existing drive torque accordingly based on the physical vehicle model, and applying additional torque difference left to right in throttle off condition if necessary.
So now when we get throttle off, we'll feel it really tuck in, which is ideally what we're going to be looking for. So getting it all set again, off throttle, rotating around nicely. And again, I just have to get used to it. I don't need to make as many corrections as I have been. On throttle, off throttle. Look at this, getting right in. Back to on throttle, off throttle, staying right in. This is so wild. And so if I just level us back out on this line and demonstrate again, on throttle, you can see we're staying sort of in, lifting off, there we go. Back on the throttle, lifting off, tucking in. This is exactly what we're looking for, which is, you know, before when we had everything off and I would go off throttle, it would kind of just go a little bit wider, and here it keeps on the exact, really target path as when we're on the throttle.
This is exactly
I've never experienced anything like this. Can we go? Nope.
Dynamic? Yes, of course.
So this is full fun mode then.
This is full fun mode, yeah.
Okay, let me just get a feel.
There is only one thing I need to tell you.
Yes.
In sport mode, we help you to turn in.
Yes.
But also help you to straighten.
Yes.
In this one, we will help you to turn in, but we will not help you to straighten the car, although you're counter steering.
Okay. So this is in dynamic mode now. So nice. But even on throttle, it kind of sends a lot of power up front, which is good. This is kind of a weird feeling, and it's probably how I would prefer the car to be set up, so we could get it in. Yep. Even on power, it comes up forward, which is very interesting. But we can. So
the thing we do in dynamic, we still take care about the cornering traction for drifting, but we are not putting it back to straight line.
There we go. Oh, it's so easy to just balance on the edge. This should be like everyone needs to do this.
But did you notice in the beginning you had a lot of exercise on the steering?
Yeah, and now I've learned it.
Now you rely on the system, and you just need to
now it's just throttle,
and that's it. Yeah.
Yeah, now I've learned it, and it's just freaking insane. This is a dream, and every car needs to have this.
At least this is what we think, but
wow, I mean, okay, so the biggest takeaways for me, we're utilizing more of the tire more of the time. And that goes for all of the tires. This is fascinating. Yeah. This could be applied in racing. Yeah, and safety stuff.
Yeah, the really important step for us, and the reason why we were doing this was, I'm promoting torque vectoring since more than 10 years now.
Yeah.
And it was always the complaint, nice, torque vectoring is super cool, but it's only a performance issue. It's only a race topic. It's only, but what does this mean in real life? And with the integration of the brake, the first time we can really say it's a performance feature, but it's at the same time a controllability and safety feature. And this is more value for the same technical effort.
It's magical because you'll make people go faster and you'll keep people safer. We're going out for just one more test, which is a new function I totally forgot that you had, which is this front axle disconnect function for permanent magnet motors. And so we talk a lot about, you know, if you have two permanent magnet motors, it makes a lot of sense to decouple the secondary axle because you don't want flex related losses. You can have up to 1 kilowatt of drag, depending on, maybe even higher in some cars. And so the strategy of coupling and decoupling is a new thing in the automotive world. I guess maybe not so much, because you've had to couple and decouple center differentials with, you know, all-wheel drive systems that can decouple. So I guess same control strategy, totally different way of doing it, new world. And we've driven cars that can decouple, and sometimes they're very smooth, and sometimes we get a thunk, and sometimes it's not coupling when we want it to, and there's a delay. So what have you done to try and improve this?
I think it's two different, I know it's two different aspects. One is the vehicle level controller. It means the high level controller. It's again based on a physical vehicle model that should know in any driving condition what's going to happen next. So most of the part, or most of the controls, are preemptively only in worst case situations where we hit an unexpected low view or low friction spot. We would have a reactive behavior by slip. This is the one thing. And the other really important thing we learned in the last nearly 10 years is that we need to adjust or scale the reconnect behavior in terms of comfort versus response time, depending on the event. So if there is a lot of masking, if there is a lot of noise in the car, if you have a slip event, you can be very quick with reduced comfort. If you do a preemptive reconnect, because you know a couple of 100 milliseconds ahead of the situation what's coming next, which we do in 95% of the cases, it's a comfort-orientated reconnect procedure.
Right, it can spin up slowly, it can mesh more gently, but if you happen to be cruising down the highway and all of a sudden, boom, big maneuver, you need that front axle connected instantly, and so you'll give up a little bit of NVH, perhaps, and just go, yeah, do whatever you can and get that thing connected. And perhaps it's, again, very rare case that this will happen in the real world, but that's when it counts.
But if you imagine a lane change or an avoidance maneuver, you will not feel it.
Really? Yeah.
Even
okay.
if you do it as quick as possible. And
So,
this is the story behind it.
When we're driving, right now it's coupled, and then this will go green when it's decoupled, this front motor. So Jordan behind the camera is really going to focus in on this. I'm going to put the car into some weird scenarios, and we're going to see when it couples and decouples. You can see you can lock it to be, I guess, just rear wheel drive or all wheel drive all the time, but here we just have it in automatic mode. So we'll leave here in a second. We have to do some weird filming at the time because there's some cool cars rolling around that we can't show you. So now we're driving normally, we're cruising along, and you can see it's decoupled. If I go hard throttle, boom, coupled instantly. 150 milliseconds, you said? Maximum?
Depending on speed, 100 to 250
or I should say
milliseconds.
minimum?
Minimum, yeah.
Yeah, so now we're decoupled again. If you zoom in on this, Jordan, here, and then all we have to do is just throttle. You would have no idea. This is the smoothest coupling. So have you driven other production vehicles with this decoupling function?
Nearly all of them,
And
yes.
isn't this just 10 times better?
At the moment, we believe it's the best solution out there.
Yeah, that's a very PR-friendly answer. I would say it is. That's pretty freaking incredible. So what we're also going to do is get the car into some harder scenarios. So I'm going to simulate a lane change maneuver where the car, may not necessarily get sideways, but you need to be ready in case the driver applies a huge torque load, or you need the additional help to vector torque forwards to pull the car out of a situation. So let's just get up there and then we'll demonstrate. Great, so I'm cruising along here. We are going to get decoupled here in a second. All right, there we go, and lane change. And you can see now we're all good in this scenario. So the moose test, it passes.
Yes, it does.
What we're headed to now is probably the hardest situation you could imagine, because we're coming in here on a super low mu surface, just as hard as ice. I'm then going to go, whoa, let's get connected. And there we go, ESP is on. We'll let it disconnect again. The goal here is to have it disconnected as much as possible. Turn, throttle, and even on sort of a sketchy situation, it's right in there. And maybe in this situation, you have to go a little bit faster than you would like, but I don't notice it. What's the hardest thing we can throw at this?
People think the hardest thing is that you stop on the very slippery surface, on the polished ice, in two-wheel drive, and then you do a full throttle acceleration, or an acceleration that is maximum possible on this type of friction, because now it's decoupled. We are only driving the rear wheels, and if we now want to accelerate as good as possible, we really have to be very quick engaging it.
So should we try this?
Let's try
So
it.
just a full launch.
Whatever you like. Yeah.
Okay.
connected. By the way, this is not the most critical situation
Right.
in real life, because we can be very quick because there is no big synchronization effort to be made because the speed is 0.
Right. This is pretty freaking good, isn't it? Is that how you prefer to drive it, sporty?
I think the best compromise, if you really want to be quick and have the maximum controllability, is the sport mode, the brake integration on.
Okay. Now it's just rear-wheel drive, right?
It's just rear-wheel drive.
And it still does torque vectoring?
Yes.
Okay, so now we're in like a full rear-wheel drive version, so we can just... Yes. So much fun to do stuff like this, even just to manage the weight of it, you know? So it's a little bit slower in this mode, right?
Yeah, but now it's rear-wheel drive, so
Now
we
it's
only
rear-wheel
have
drive.
half of the power available.
Right.
This is the reason why we say typically an all-wheel drive can drift better than a rear-wheel drive.
This drifts pretty well. Just heavy, you have to get the weight balanced. I could do this all day. Thank you so much.
But you can do one more loop in all-wheel drive.
Yeah,
for
let's do
example,
that.
with dynamic,
Okay.
whatever you
As
like.
long as you're not car sick or
No, I'm not.
you're used to this, I guess. Yeah, I feel like if a little bit more time in the car, this is sort of exactly how I would want this drivetrain to work. Once again, in all-wheel drive dynamic, right?
All-wheel drive, dynamic brake integration.
So brake integration. A little bit of mowing the grass there.
Mowing the grass.
Yeah, it needed to be trimmed a little bit. Really quite a good time. And I kind of don't want to give you your car back. I think we have to take this back to the US.
Everything in life is a matter of money, isn't it?
Yes. So if we write a big enough check, Magna will let us keep this. Thanks so much for watching another Out of Spec Reviews video. Can't thank you enough. And every time, we mentioned this when we drove the last one, but every time we're in a Magna vehicle, we always destroy tires. It's
That's okay.
It's a good company.
That's okay.
See you on the next one. Bye-bye.
See ya.